In this and the video that follows, we're going to learn how to calculate pH and pOH. Before we go off and jump right into pH and pOH, though, we should review a little bit here of both chemistry and some math. We just recently went through the section that talks about the ionization of water, and in pure water it's found that the hydronium ion concentration, which has to be equal to the hydroxide ion concentration because water splits apart evenly into hydronium and hydroxide, those are both equal to 1 times 10 to the negative 7th molar for pure water. Okay, and we also then established the ion product constant, or the ionization constant for water, is those two things multiplied together, and that value would be 1 by 10 to the negative 14th. We just leave the units off of that. So let's think about this. What would happen if an acid were to be put into this water? You may remember that we established that this relationship is the same even for dilute solutions. So if we just put a small amount of acid into water, what do you think that will do to this relationship right here? And also, what happens if we put a base in? So why don't you pause right now and think about that, jot down some thoughts about what might happen when you put acids and bases in. Okay, so hopefully you thought about this. An acid is something that increases the hydronium concentration because an acid provides hydrogen ions. They react with water. So the hydronium ion concentration would go up. This value would go up. And since it's these two multiplied together, it has to always be this value of 10 to the negative 14th, 1 times 10 to the negative 14th. When hydronium goes up in an acid, hydroxide goes down. Right? And in a base, bases have hydroxide. Hydroxide would go up, which means hydronium would have to go down. So in an acid, this one goes up, the other goes down, and in a base, it's just the opposite. All right, now, what we're also going to do here is get a simpler way of expressing the hydronium ion concentration rather than a big, long, nasty-looking number. And we're going to do that by using logarithms. Now, logarithms, hopefully you've learned in math. The term logarithm itself just means exponent. So to take the logarithm means what? Well, if we look at this example, what's the logarithm of 10 to the 4th? If logarithm is exponent, the logarithm or exponent of 10 to the 4th is just 4. So the logarithm of 10 to the 4th is just 4. And what's the logarithm of 10 to the negative 9th? We could rewrite that as what's the exponent of 10 to the negative 9th? Well, it's just negative 9. All right, now, what if there's a number in front of the times 10 part? So, for example, what's the log of 2.5 by 10 to the 3rd? I can't do that in my head. Probably there aren't a lot of people who can, but if you just punch that into your calculator, and to punch in your calculator, you're just going to push the log key, and you're going to push 2.5, and however you put this in, if you push times, and then 10 raised to the 3rd power, and make sure you're being careful and putting parentheses around this, and then push enter, you will find the answer to this to be 3.3979 blah blah blah, and when we round that off it's going to have to be 3.4. Okay, so what you should do now is, here's another problem. Let me grab this, put it out of the way. The log of 7.9 by 10 to the negative 12th. So I'm going to pause here for a second, and you should push pause and go ahead and punch out in your calculator and see what you get. Okay, hopefully you got that punched in and you got the answer of negative 11.1. Negative 11.1. Okay? So now, next, we're going to go the other way to anti-logarithms. So the logarithm is the exponent, so the anti-logarithm is what happens when you put the exponent back on. So the anti-log of 2 would be 10 raised to the 2nd power. And the anti-log of negative 11 is 10 raised to the negative 11 power. Okay, and again, we can have some wrinkles put into this. The anti-log of 6.5, well, we could raise 10 to the 6.5 power, but it's not proper to have a fractional or a decimal exponent. So there's a couple ways you can do this. You could push the second button and the log button, which is labeled 10 to the x, and then put in 6.5. When you do that, you're going to get the answer of 3.16 by 10 to the 6th. Okay, or you could just do it by typing in 10 and then the caret sign to raise the power and putting in 6.5. Right, so for practice here, just take a second and pause and do the anti-log of negative 8.6. Okay, so hopefully you've taken the time to put that into your calculator, and if you have, you found that it's 2.51 by 10 to the negative ninth. 2.51 by 10 to the negative ninth. All right, that's the end of logarithms, and next we're going to start looking at pH.